Hi guys, welcome back. So this week's lesson, we definitely have notes. There's going to be some new vocabulary. We are going to be going over how to do operations on polynomials, and I'm super excited about this. So this is my math notebook. Come along with me as we take some notes. Okay. So we're going to start with some vocab. Hopefully this is review, but if not, that's okay. So first off, when you hear the word mono, take a second and think, what's another word that starts with mono? If you thought monotheistic, awesome. Okay, mono means one. So a monomial is going to be a polynomial expression with one term. So you should be writing the notes with me. With one term. And here's an example. 5x is a monomial. 10y to the fourth power is a monomial because there's no addition or subtraction. 7 is a monomial. Okay, so as long as there is just one term, it is a monomial. Binomial. What do you know that starts with bi? You were thinking bicycle, right? I know you were. 2 wheels. Every word that starts with bi means two. So binomial is a polynomial expression with two terms. All of these vocab words and notes are going to be posted in Google Classroom, so don't forget to do that. So 3x plus 6. Notice that there is one term, two terms, and a plus sign in the middle. That's how you know it's two terms. Another example, 15x squared minus 9. Okay, so two terms, they have different variables or exponents. Another one, 6y to the 7th plus 8y. Two terms separated always by a plus or a minus sign. And the exponent is different, so you can't combine them together. Next up is trinomial. What starts with tri? Tricycle, absolutely. 3 wheels. So anything that starts with tri means 3. Bi is 2. Mono means 1. Okay, so a trinomial is a polynomial expression with 3 terms. For example, x squared plus 8x minus 9. Like a quadratic, that would be an example in this case. You can also have a quadratic that's a monomial. For example, x to the 5th. I'm sorry, what am I saying? X squared. I meant to say 5x squared. Okay, a polynomial. So a polynomial is where it really encompasses all of these. So see how all of these had the word polynomial in them, right? So a polynomial is a mathematical expression where all the exponents are 0 or positive. So there can be 0, 1, 2, 3, etc. 4, 5, 6, 7. Can't have a negative exponent, okay? And it cannot have a variable in the denominator. That's the bottom of the fraction. Okay, I'm going to just scroll up here. So some examples of these are going to be, for example, all the ones we just saw. Another example would be 10x to the 3rd minus 4. Okay, that's an example. 8 is a polynomial because technically, if you didn't know, there is an x to the 0 power next to it. Okay. And yeah, all of these trinomials, you can have x to the 5th minus 3x to the 4th plus 10x squared minus x plus 8, that's a polynomial. So these are all examples. What is not a polynomial, for example, would be 10 over x plus 1. So this is not a polynomial because you have an x in the denominator. Another example that's not a polynomial would be 6x to the 4th plus 8x to the negative 2. This one is not a polynomial because you have a negative exponent. Okay? Alrighty. Last two vocab words for now. And those are constant. So you may know this word already. Constant means it doesn't change, right? So a constant is going to be a number with no variable. Because a variable means that it varies, it changes, so a constant doesn't change. 10x plus 6, this right here is the constant. So the 6 is the constant. I should do it in the same color, shouldn't I? Okay. A coefficient is the number in front of the variable. And as always, pause it at any point. So 6x squared plus 10. We've got green going on here. So the 6 right here is the coefficient because it's in front of the variable. Awesome. Doing great so far. Okay. So now we're going to continue. So first we want to see how would I simplify something like this and associate a lot of the vocab we've been learning. So the first thing I always have to do is write something in standard form. I pay attention to the exponents, okay? It has to go from highest exponent down to lowest. If I have an x with no exponent, there's an invisible 1 there. If there is no variable, like here, that's 0, right? The exponent's 0, so that one doesn't exist. So this is the highest exponent, it's going to go first. So I write negative, you always carry the signs with it, 10x to the 7th. The next one is the 5, so that goes next. Negative 6x to the 5th. Sorry, my neighbor is vacuuming. Then plus 8x, and the constant always goes at the end. So this right here, we're going to label all these parts, is the constant. Okay. This whole term right here, because it's in front, is called the leading term. Sorry. Okay. The blue. The negative 10 right here is called, okay, the leading coefficient because it's the coefficient of the leading term. And then we want, this is a polynomial because it has no negative exponents and the variable is not in the denominator. And now we want to count how many terms there are here. So let's pick a different color. So we've got the first term right here. We've got another term. They're always separated by plus or minus. Okay, so this is 4 terms. 4 terms. So that would be called a polynomial. If it was 3 terms, it would be called a trinomial. 2 terms, a binomial. And then the last thing we're going to go over right now are the types of polynomials. So make sure to pause at any point to write down. All of this should be in your notes because it's going to come up a lot, especially in the Delta Math. Okay, so the types of polynomials. So they're based on the degrees. That's how we name or classify polynomials. So if it's got a degree of 0, we kind of just saw that. That is called a constant. Okay. And an example of that would be 7. So it's a number with no variable. Number with no variable. You'll notice I tend to write in shorthand a lot. If you don't know what something means, just ask. The next one is when you have a 1 as an exponent. So for example, 2x. That you know, but you may not know is called linear. You're like, oh, I've heard linear. Like think of y equals 5x plus 4, right? It has x to the first power in it. Okay, the next, when it's to the second power, is called quadratic. I know you've heard that one before. And that is when you have x squared. The next is called cubic. And that is when we have x to the third power. The next is called quartic. That is x to the fourth power. And the last one is called quintic. And that is x to the fifth. They keep going, but you don't really need to know anything past quintic. Okay, so take a pause, write that down. You're definitely going to need to have these memorized down the line, but for right now, you just need to have them in your notes. Okay, now we're going to actually get into the meat of this. So how do we actually do operations on polynomials? Let's start with something a little easy, which is multiplying polynomials. I know you've seen this before. So I'm going to show you two methods to do this. The first is the box method. So the box method is where we set up a box, and since this has 3 terms, I'm going to put 3. Okay, and since this guy has 2 terms, I'm going to have 2 that way. So we're going to have negative x plus 5, and then we'll have 2x squared minus 3x minus 4. Notice that the sign stays with the term, okay, and it goes right next to it. It doesn't go in between. Okay, so now we just multiply. So 2x squared times negative x is negative 2, and remember, if there's no number there, there's a 1. So that would be x to the third, because you're adding the exponents, because you have 2x's here. X squared times x means x times x times x. So that's 3x's being multiplied. Erase that. Okay, the next one we would get positive 3x squared, okay, because x to the first times x to the first would be x squared. Here we would get positive, because negative times negative, 4x. Here we would get 10x squared, because again we're multiplying what's above it and what's next to it. Negative 15x to the first, or just x, and the last one would be negative 20. Now I look for like terms. So I can see that they have to have the same variable, same exponent. So this guy and this guy both do, and this guy and this guy both do. And now I'm just going to add everything together. So the highest exponent goes first, standard form. So that's 2x to the third negative. Then I combine these two together, and I get positive 13x squared. Then I combine these two together. Notice I give it a different underline. I don't give a straight underline for everything. Negative 11x, and then this has nothing to add with, so it just comes down. And that is my standard form. Okay, so that's the first method. Now I'm going to show you method 2. Method 2 is distributing. I want you to write them both down, but then you can choose whichever one you want to do. You don't have to do both of them. 2x plus 1 times x squared plus 9x minus 3. Okay, so now we draw the distributing arrows. So from the negative 2x, I distribute to everything that's in the next parentheses. Remember, like FOIL? First, outer, inner, last. I'm sure you remember that. Now we're going to distribute the 1 to everything in the second parentheses. We're going to be doing a lot of singing this year. Just a heads up. Okay, so now I'm going to multiply. So negative 2x times x squared is negative 2x to the third. I'm going to scroll up and zoom in a little bit. Negative 2x plus 9x is negative 18x squared. Negative 2x and negative 3 multiplies to positive 6x. Now I do the yellow or orange distributing. 1 times x squared, positive 1x squared. Notice I don't leave it blank in the middle. I have to put the plus. 1 times 9x is plus 9x, because between terms there's always a plus or minus. And 1 times negative 3 is negative 3. Now I'm going to do all the funky underlining. So these have the same exponent, so I give them the same underline. These have the same exponent, so I give them the same underline. The other guys just come down on their own. I add those two together, and I get negative 12x. Add those two together. Oh, I'm so sorry. I added the wrong ones together. Add the squigglies together, and I get negative 17x squared. Add the circles together, and I get 15, positive 15x, and then bring down the negative 3. All right, so that's the second method. Pause it, write it down. I'm going fast. So now we're going to take that idea and we're going to move it to the next level. So you can do the box or the distributing method. I'm going to show distributing, but whichever you do is fine. So I'm going to zoom in a little bit. Okay. So there's 3 terms here. I'm going to be distributing each of them. Distribute. Actually, you know what? Let's do the box method because I think more people like that method. Okay, so there's 3 going this way and 3 going this way. So I have 3x squared minus 8x plus 1, and I have x squared plus 7x minus 9. Do it exactly the same way now, okay? So we get 3x to the 4th, because remember, squared and squared, that would be 4 x's being multiplied. You're multiplying, you get positive 21x to the 3rd, negative 27x squared. Here you'd have negative 8x to the 3rd, because there's an invisible 1 right there. Again, that invisible 1 makes this, oh my god, what is that, 50, 52, 54? Why do I always blank out when I'm multiplying 8 and 7? For some reason, that's the hardest one for me. 56, my goodness. Okay, so negative 56x squared, positive 72x. Here we got x squared, we got 7x, and we got negative 9. This is where it gets a little tricky. So we got to pay close attention to the like terms. We've got an exponent, x to the 3rd, and we've got an x to the 3rd here. Any more? That's it. Now we got x squared, x squared, x squared. As you're doing this, you may see a pattern. I don't know. Do you see a pattern? All right, and now we just combine. So the highest exponent goes first, 3x to the 4th. We add the yellow highlighted because they both have x to the 3rd, and we get negative 13, and x to the 3rd stays the same. We add all these guys together. Remember that there's an invisible 1 in front there. So we're adding 1 plus negative 56 plus negative 27, and we get negative 82, x squared stays the same. We add the pink guys together, and we get positive 79x, and we bring down the minus 9. All right, pause it if you need to take a second, watch it over again. Let's do the last couple types of problems. So when you have an exponent, the exponent tells you how many times to write it. So write that down. How many times to write whatever's in the parentheses, okay? So 2 tells us we're going to write what's in the parentheses 2 times. Now you can do the box method or you can do distribute. I'll mix it up and go distribute this time. Okay, so I multiply the x to the 3rd times x to the 3rd, and I get x to the 6th. I do x to the 3rd and negative 7, negative 7x to the 3rd, because it's like there's an invisible 1 in front, right? Negative 7 times 1x to the 3rd, negative 7x to the 3rd, and then negative 7 times negative 7, positive 49. I look for like terms, and I've got them. And I combine those together to get a number you're adding together. Variable stays the same when you add, and then just bring everything else down. X to the 6 and positive 49. Okay, this one is a little trickier because now it's telling me I have to write it 3 times. So I write it 3 times. Okay. Now, this is how you do it. You're like, what? I don't know what to do now. You do 2 at a time. So first, you're going to distribute these guys, okay? Work that all out. Use whatever method you want, and you end up with x squared plus 12x plus 36. You put parentheses around it because you're not finished. And now we're going to bring this guy down. X plus 6. Now we're distributing every term here to this. So we've got boom, boom, down, down, and then the 36 as well. Okay, so x squared times x to the third. X squared times 6, 6x squared. Now we go to the 12. 12x, so I'm distributing that twice. 12x times x is 12x squared. 12x times 6 is 70. Yeah, 70x. Oh no, I'm running out of space. And lastly, I'm distributing the 36. So 36 times x, I'm just going to continue it right here, is 36x. And 36 times 6, I gotta be honest, it's 216. Plus 216. Again, when I'm looking for my like terms, I make sure to give different types of underlines. So I'll give a straight underline to those guys and a squiggly to those. And now I combine like terms. So x to the third plus 18x squared plus 106x plus 216. Okay, we're almost through. So pause it, write it down if you want to break this up so it's not too confusing. Okay, last part, adding and subtracting polynomial expressions. So a couple key things to look for the words sum and difference. Sum means add, I'll make it nice and big, add, and difference means subtract, okay? Couple key things, remember that you need to have parentheses. So the first thing we're going to do, if it says sum, I'm going to write this one first, and then this one second. So it goes parenthesis 2x squared plus 8x minus 9 plus, because it's sum, parenthesis, negative 3x squared minus 2x minus 1. Now remember that if there's no number in front, there's a 1 there. No number in front, there's a 1 there. And then you just distribute that 1. Now in this case, because when you multiply by positive 1, it doesn't make a difference. So it's just going to stay the same. But we do that to eliminate our parentheses. This stays the same as well. Sorry, I should have not put that. Minus 2x minus 1. And now we can just combine like terms. So 2x squared, negative 3x squared, different underline. And so all different underlines. And now I add those like terms together. Negative 1x squared, positive 6x, and negative 10. Use a calculator when you're adding. That's absolutely fine. This is where it gets a little trickier, when we have difference or subtraction. So in this case, it says, what is the difference of these? So this one's going to go first in parentheses, and this one's going to go second in parentheses. So we write it as parenthesis negative 5x squared plus 10x minus 1 minus parenthesis 6x squared plus 3. Now we're going to put that 1 in front of each and distribute that. This is where it makes a difference. Here, positive 1 is going to stay the same when you multiply by it. But negative 1 is going to change this. So negative 1 times 6x squared becomes negative 6x squared. Negative 1 times 3 is negative 3. And then you just go ahead and combine like terms. Okay, the 10x has no like terms. But remember that you do have to write it in the right order. So this is negative 11x squared. Exponent stays the same. The 10x, positive 10x, comes next. And the negative 4 is that constant, goes at the end. Okay, and this is it. So now we get to the harder ones. So simplifying algebraic expressions. And I think that this is the last one, yeah. So you always do distributing exponents and distributing first. So step 1, simplify exponents, then distributing. So in this case, we don't have exponents, but we have distributing. So we multiply negative 8 times negative 8a, positive 64a, negative 8 times positive 1, negative 8, and bring down anything you haven't used yet. Now, let's combine like terms, and you end up with 59a minus 8. Okay, so step 2, combine like terms to simplify. Okay, let's take a look at a slightly more complicated one. Written as a simplified polynomial in standard form, what is the result when 2x minus 7 squared is subtracted from 6x squared minus first? If I'm taking something from something else, then this is what I'm going to be starting with. So this is going to come first in parentheses because it's subtracting from that, and this guy's going to come second in parentheses. So the way that I write that out, hopefully you got that first one down, is I write 6x squared minus 5 minus, because it's subtracted, parenthesis 2x minus 7 squared. Now remember that we just said, I'm going to just slide this over, that the first step, okay, step 1 is exponents and distribute. So we do have an exponent here. That exponent right there tells me that I have to write that twice. So I'm going to do that. I write 2x minus 7 twice. And now you're going to do the box method or the FOIL method. I'll just do FOIL. Okay. So when I distribute the 2x times 2x, I get 4x squared. 2x times negative 7 is negative 14x. Now I distribute the negative 7. So I get negative 14x and positive 49. And I combine like terms. I end up with 4x squared minus 28x plus 49. But remember we said, if we're not at the end yet, we have to bring down parentheses. So everything else has to come down exactly as it is. Parentheses only disappear when you're at the end. And you've already done the operation for them. So remember I put the 1 in front of both parentheses, and I distribute that sucker. Doom, doom, doom. So the first one stays the same because it's a positive 1. This I'm distributing negative 1, so that's negative 4x squared, positive 28x, and negative 49. And then you combine like terms. So this gives us 2x squared plus 28x and minus 54. And that is it for this week. I know that was a lot. Go back, rewatch parts that you need help with. Make sure you have great notes on all of this. And I will have tutoring this week, so it's posted in your Google Classroom if you have any questions. Post the notes in Google Classroom. You must show work. As you can see, there's a lot of work to show, but you can choose the method that you want to do. So if you want to do box, cool. If you want to do distribute, cool. You cannot just give me an answer and say I did it in my head. You have to show me the work. Have fun. I am giving extra credit to anybody who draws a smiley face in their notes and writes, I love math. Because I do. It's so much fun. Have fun with this. You have until next Monday. It's due the day 6. If you have any questions, come to tutoring. Bye-bye.